Hello, hi, this is Rani Ahmed with you, and this is our first episode in this series of solving Haskell programming language problems, okay, using the lecture coded as CIS, or the subject coded CIS194, okay, and this is one of its homework questions. And you can find those questions in this address. Just a second. Okay, here. Cool. And if you want any questions, you may ask them also on this IRC chat channel, okay, using this server and this grouping location. Okay, this is a room on IRC. You can chat with so many people, they can explain everything to you. Now, what's the problem here? The first problem is validation of the credit card number. Okay, we want to make sure that this number is a correct and valid number that can be used to purchase anything online, for example. Okay, so instead of them, the ATM machine, you know, to make sure that this number is valid through finding it recorded somewhere on the database, they made a formula, okay, a calculation formula. So let's see how this formula works. Now, it says, like here, double the value of every second digit beginning from the right. This is how you start with it, okay. That is, the last digit is unchanged, the second to the last digit is doubled, the third to last digit is unchanged, and so on and so forth. Oh, yes? So, for example, if I started with 1386, okay, so 6 is the first one to the right, I go and double 8, so I can get 16. I skip this from the right, okay, then I go to the one before it, okay, and double it. So every second digit beginning from the right. Cool? So as if you're saying double everyone, okay, and double double one, skip one, double one, skip one, okay, because if you see that the number here is having a length of an even number, which is 16, okay, see, 4 digits, okay. However, I solved it in a way that even if this doubling, even if there is an additional number here, like it is 15 digits, okay, it works too, by just skipping the first one here and dealing with the rest here, okay. So we move on to the next step, which is add the digits of the doubled values to the undoubled digits from its original number. For example, if I have 2, 3, 16, and 6, which is this one, I take it and make it like this: 2, 3, 1 plus 6 here is the 16. Okay, this is where the change goes. So between us, if the number exceeds the number doubling, okay, exceeds 10 or is equal to 10, okay, you will have to split that number, okay, because you know the maximum you got is 9. From 0 till 9, this is what the digit that you have on this starting point, okay. So you got the point. Okay, so I got now this new number from this sum, okay, and then I take it and divide it by 10. So if the result of the remainder when the sum is divided by 10 is 0, then the number is valid. If not, it's not valid, okay. And here the remainder is 8, so this is not a valid number. Cool. Now let's see the code. Now this is the doubling function, okay. I take a list of integers and I get a new list of integers through this after I double it, okay. So it starts with, if I have an empty list, of course there's nothing to double, so I return it back. So if I have a singleton list, okay, this means if I started with just 2 elements in this list, the first one will not be doubled, the second will be doubled. So if that second one does not exist, I'm left with this one, which is not doubled, so I return it back as this. Okay? Now, if I have a normal list, a complete list of integers, so it will be the first one, the second one, and the rest of the list. Okay? So, because if we look at it, okay, let's imagine this is an empty list, okay, at this place of the doubling. So you start with the first one here, you skip it, the second one you double it. Okay, so if we replace this with the rest of the list, it has to go also with the doubling process. Okay, and you know, we are consing this with the rest of the doubling process. Okay, so consing means concatenating the data, the items of the list. Okay, now this is where the solution that I made for even number, okay, just for education purposes, teaching purposes. So I start with the list, okay, and supposedly that it is formed of x and the rest of this list, which is xm. Okay, this is represented by or defined by xm. So if the length, this is a function that's part of prelude, which is the length of this list is when divided by 2 gets or gives a remainder of 1, which is not 0. Okay, this means it is an odd lengthy list. Okay, like odd in length list. So it has an odd number of integers in this list. So I take the very first one, this one, okay, and I cons it with the rest of the doubling of xm. Okay, you know, xm is the tail of this list. So this is the opposite way around. Okay, with this, but this time I take the whole list x plus xm. Okay, and it would be better that I use the variable list directly here. Okay, now this process is the one that's responsible for making something like 143 as a number. Of course, we will not reach that big a number, because you know the numbers, when they are doubled, they are between 10 and 99. Okay, or even 81, to be frank, because 9 times or 18. Okay, because we're doubling now. Anyway, so it won't exceed like this big. Okay, so anyway, this is a function that will not will change, for example, something like 143 to 143 as a list of digits. Okay, now it starts with, if I have an input of 0 as a number, it will give me an empty list. Okay, there's nothing to do. Now if I have x as any number, okay, so I will divide by 10, okay, and get and by dividing by 10 it will be like this. So if I divide by 10, this is gone, I'm left with 14. Divide again, okay, the 4 is gone and I'm left with 1. Divide again, okay, and you'll be left with nothing. Okay, but every time I divide by 10, okay, the remainder is the digit itself. Okay, and this is how I'm consing, okay, or concatenating the results of the division. Okay, and every time I call dex to do the division here by 10. Okay, Now, next thing is, this is just an explanation on how to do your own length function, okay? Length of the list function. So if I start with an empty list, I get 0. Of course, there are no elements in this list. And if I suppose that the list is formed of x and its list or its tail xs, okay? So every time I ignore x, but I just say there's 1 here, okay? Because this is a single count, you know, or like I omitted just once, so of this complete list, which is the x, and then I go back with xs, okay? And split xs again, the tail, and also get a new tail, and so on and so on and so on, by recalling L again, okay, until you get this base case, okay? Now, this is just renaming, okay, of summing the digits of the of the number that's given by digs, okay? You know, I get 1, 4, 3, so the list will be 1, 4, 3, okay? So this one will give me 1 plus 4 plus 3, it will be 8, okay? Now, here, okay, you know, I input a list of integers, okay, like in the example here. This is the list of integers that I have, okay, and yeah, this one, I mean this one, okay, and it will go over this list of integers, okay, and every time it will go to sum of the digits. So this way you will convert the number of 2 digits to a normal number, okay, then sum it, okay, then if that's another, even if it's if that number is just a single one, you know, it will be converted to a single digit value, okay, and we'll sum, okay, similar to the fashion of L here, and total is working similarly to L, okay, but instead of adding 1, I'm adding what? A sum of the digits, okay. Now, and you know, when you have just a single digit, there's just nothing to do, it will return it back. Now, this is the validation. I take the integer and give me the string, either of which, whether it's a valid credit number or invalid credit number. If I divide by 10, I get the remainder, whether it's 0 or not 0, okay? And this function will tell me what will happen with x. Now, I'll come to the hard part here, and how to read from the keyboard the input, okay, of a string, and convert it back into a list of integers, because getLine will read a string, okay, but between us, really, it's going to read a list of chars. Cool. Now, the problem is that read itself reads a string. Does not read a list of chars, okay. Now, to convert the list of chars, I will have to use the cons plus an empty string value. So with the help of map, it will take every element in this char list, okay, character list, and see this place here, okay, this one here, okay, where I put this hat, okay, sign. You have to imagine that I'm using map every time a character from that list of characters and apply it to here, and then read will use it. Okay, and when read uses it, it will convert that into an integer, but because map works with or gives us a list, okay, and read is reading to give me an integer, so it will be a list of integers. Okay, so I have to delete this because this is not correct, leaving it as is. Okay, now, so all I advise is just to memorize this, and you know, if you wanna convert it to something else, this is just the result of the reading, okay, into a set of numbers, or a set of characters, or set of whatever, okay, or set of strings. Now, you just try this, okay, and you'll know how it works. Now, doubled, okay, is kn of f. Okay, so what I've read, okay, I send it to kn, okay, and the doubled list will be given to total, okay, and then the total is given to m, and validate will do its job, and I get the result. And I also, just for clarity, I added the conversion result, okay, by showing the value of f plus the result itself, okay, whether it's valid or invalid. So if I just run this app, okay, or run this code, this is the number I have. This is a true number, by the way. This is a completely true number, okay. This is just a card that I found somewhere on the streets, okay, but I know it was just cancelled, okay, because it was lost, and it still hasn't expired, by the way, by the date that's recorded on this number. So this is the CC number, the number that I've read, this one. So it's represented by the CC number, the credit card number, and it's converted to a list of integers. Okay, so this is the conversion, and it will tell you finally it's a valid number. Okay, that's all. So we'll stop here. We'll take the Towers of Hanoi after, okay, within this homework, okay, and this is the Towers of Hanoi, and all I need from you, just for now, click the subscribe button, and click the like button, click the ads, you know, if you like this explanation, and thanks for watching.